There is a lot of buzz circulating about a new model called Gemma 4 with claims that it is released under the Apache 2.0 license. However, before we can architect a proper production pipeline, we must ground ourselves in the actual facts. Current research indicates that Google has not released a Gemma 4 iteration, and the existing open-weight models, including the Gemma 2 series, operate under the Creative Commons Attribution 4.0 license. This distinction is critical because the licensing terms dictate how enterprises can legally deploy these models for commercial gain. The Apache 2.0 license would allow unrestricted commercial use, but the current Creative Commons license imposes specific restrictions that require careful legal navigation for business applications. This discrepancy creates a significant knowledge gap that every engineering team must address before writing a single line of code. Now consider the core challenge regardless of the specific model version. The real story here is the shift toward open-weight models and what that means for infrastructure. When you move from proprietary closed models to open weights, you gain control over the weights themselves, but you also inherit the responsibility of the entire stack. This is where the MLOps pipeline becomes the most critical component of your architecture. You are no longer just calling an API. You are managing the lifecycle of the model from ingestion to inference, and the trade-offs between edge and cloud become the defining factor in your cost and latency strategy. Let us think about this using an analogy of a delivery service. Running a model on the cloud is like using a centralized distribution center. You send a package to a warehouse, they process it, and send the result back. This is reliable and scales easily. If you need more capacity, you simply order more trucks. The downside is that every package must travel across the network. For real-time applications, that network latency adds up. It is like waiting for a courier to pick up your package and deliver it back to your doorstep for every single request. In an enterprise setting, this means your data leaves your secure perimeter, and you pay a recurring fee for every transaction. Now, contrast that with edge inference. This is like having a local factory in your own building. You keep the raw materials and the machinery on site. The processing happens instantly because there is no travel time. The latency drops to near zero, and the data never leaves your premises. This is ideal for sensitive enterprise data where privacy is paramount. However, the cost structure changes completely. You are no longer paying per transaction. You are paying for the hardware, the electricity, the cooling, and the maintenance of the machinery. You need enough RAM to hold the model weights in memory. You need enough compute power to run the inference without overheating the device. If the model is too large, you simply cannot fit it on the edge hardware. This brings us to the specific trade-offs of the Gemma family. The smaller variants, often around 2 billion parameters, are designed to fit on consumer hardware. They require significantly less memory, perhaps as little as 6 gigabytes of RAM. This makes them viable for edge deployment on devices that already exist, like workstations or dedicated edge servers. The larger variants, ranging up to 27 billion parameters, offer better reasoning and capability, but require substantial cloud infrastructure. They cannot run on standard edge devices without specialized accelerators or significant memory upgrades. So how do you architect a pipeline that handles both scenarios? You need a hybrid approach. The pipeline must be capable of routing requests dynamically. If a request requires high-level reasoning or involves sensitive data that must stay local, the edge node takes it. If the request is computationally expensive or requires a larger context window, the pipeline forwards it to the cloud inference endpoint. This requires a robust orchestration layer that monitors latency and cost in real time. You are essentially building a traffic controller that decides the best path for every single inference request. Implementing this requires a solid foundation of monitoring and observability. You need to know exactly how long an inference takes on the edge versus the cloud. You need to track the cost per token for both environments. If the edge hardware becomes too expensive to maintain relative to the cloud API costs, the pipeline should shift more traffic to the cloud. Conversely, if network latency spikes or cloud costs rise, the pipeline should favor the edge. This dynamic routing is the key to a production-grade system. It is not a static decision made at the beginning of the project. It is a continuous optimization loop that adapts to changing conditions. Furthermore, the licensing implications affect how you fine-tune these models. Since the current Gemma models are under a Creative Commons license, you must ensure that any fine-tuned versions comply with the attribution requirements. This adds a layer of compliance tracking to your MLOps pipeline. You need to log exactly which base model version you used, who modified it, and how it is distributed. If you were operating under an Apache 2.0 license, this would be less restrictive, but with the current license, compliance is a non-negotiable part of the deployment process. In an enterprise scaling context, the decision ultimately comes down to the balance between control and convenience. The edge gives you control over data and latency, but demands more upfront capital expenditure. The cloud gives you convenience and scalability, but introduces recurring operational expenditure and potential latency. A mature MLOps pipeline treats these not as binary choices, but as complementary resources. It allows the system to utilize the edge for low-latency, privacy-sensitive tasks and reserves the cloud for heavy lifting and complex reasoning tasks. As the landscape evolves, the distinction between edge and cloud will likely blur. We are seeing a trend toward more efficient models that can run on increasingly capable hardware, reducing the need for cloud dependency for many tasks. But for now, the hybrid architecture remains the most pragmatic solution for enterprises serious about deploying open-weight models. The goal is not to eliminate one or the other, but to orchestrate them so that the user never feels the difference. They simply get the response they need, fast and reliably, regardless of where the computation actually happens. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.